Hello and welcome to Food Safety Fridays. My name's Simon Timpley from the International Food Safety and Quality Network. Delighted to say today our guest presenter is Rob Rogers from Mettler Toledo, and today's topic is foreign material detection programs, building beyond compliance. It's great to have you back, Rob. Good morning. Where are you joining us from today?
Tampa, Florida. Nice, sunny, and hot this summer, so enjoying it. Ready for a nice weekend.
Great. Sounds great. And actually, in the UK, in Manchester, it's lovely sunshine today. It's about, we go out in centigrade. It's about getting up for 20 degrees centigrade, which is into the 70s Fahrenheit. So big surprise for us. But yeah, we're enjoying it. We'll all be complaining soon. But yeah, Rob, you've had a long affiliation with IFSQN. I can't even hesitate to say how many years. You've done lots of webinars, haven't you?
Yeah, it's got to be well over a decade, if not approaching two.
Definitely. See, yeah, I'd go as far as say maybe like getting on for 15 years. We've been doing webinars now since 2015, actually. So it's over a decade anyway. Yeah. So anyway, welcome everybody. Tell us where you're joining from in the chat. Tim from Michigan in the US. We've just been doing a tour of the US with Rob of all the places he's been that I want to go. Sonia from Portugal, hello. John from India. Brennan from Trinidad. Leanne, enjoying the sunshine in Manchester. Yeah, there we go. It's a small world on Food Safety Friday, so welcome. I'm going to play the sponsors ads and then we'll get straight into Rob's presentation. Oh, I finished a bit abruptly. Yeah, great video there from Mettler Toledo, and then straight into Rob from Mettler Toledo. So I'll leave it to you, Rob. I'll be back for the Q&A later. Do you want me to make that a little bit bigger, your thumbnail? Will that interfere, or is that okay?
You can make me smaller. That's fine. I don't want it to interfere with any script on the screen or anything. So people already know what I look like, and they don't need to see my ugly mug.
Okay. Right. Okay, I'll be back for the Q&A.
Okay. Appreciate you as always, Simon, and the IFSN community. Certainly one of the most engaged communities that I've ever run across in the space. And so I'm happy that you've all joined here today, and hopefully you'll enjoy the presentation. My presentations with IFSQN, they tend to get shorter and shorter and shorter on the presentation time because you're such an engaged community, and I like to leave time for any questions. So please don't hesitate to be asking some questions along the way, and we'll surely get to them towards the end. And again, thank you for joining. Today we're kind of talking about going beyond compliance when we're looking at items regarding physical contamination. So we're going to kind of go over just a quick overview of some of the issues related to contamination, various recalls, various GFSI type standards, and their top non-conformances related to, or you could relate them to, potential contamination concerns. We'll go over a quick overview of the technology. I'm sure a lot of you are familiar with not only Mettler Toledo, but also the technology itself, metal detectors, X-ray systems. And then I like to really spend some time on the value of inspections throughout the process. I find that historically a lot of these technologies are deployed towards the end of the line. And I believe there's really true value in having a more holistic approach to where these systems are located and the value that it can help bring to an organization. And then, of course, we'll leave time for that Q&A. So obviously, compliance is one of the major things and reasons behind why solutions like metal detectors and X-ray are deployed into facilities. Not only the compliance side of it, but obviously protecting the brand, protecting your consumers. But the compliance side of it is a lot of times where we are able to get the direct feedback on how we're performing in these areas. So I'm sure you're all very familiar with a lot of these standards: BRC, SQF, IFS, FSSC 22000, all organized or recognized by the GFSI group as very, very prominent food safety management programs. Then, of course, you have the pillars of the regulatory aspect in each of the territories that we're working within. Obviously, in the U.S., we have the FDA and the USDA, the Canadian Food Inspection Agency up in Canada. So each territory really has their own kind of regulatory requirements. Those, of course, are law, and kind of we have to do them based on law. And then a lot of these programs here, like the GFSI recognized programs, that's kind of that second tier where it's not necessarily a territorial focused organization. They have more broader reach and they kind of cross borders. And so that's the second pillar that I look at. You have your regulatory pillar, the laws and the regulations. Then you've got your globally recognized type standards like these that we kind of are also attempting to comply with. And then oftentimes you will have your own direct customer requirements. If you have a particular customer brand that you're selling to or providing product to, they may have specific requirements, and all of them may have similar requirements, but each one of them could be a little bit different, sometimes even more demanding. I look at the regulatory side as kind of being non-prescriptive. They kind of tell you what to do, but not necessarily how to do it. You get a little bit more detail with these GFSI groups where they'll kind of have certain sections that are pertaining to metal detection and X-ray and certain things that they want you to do around those programs. And then you have, of course, your direct customer demands, and they're often the most prescriptive, where they tell you when, how, and who to do it, who's going to do the activities. But these are a lot of a big focus as to kind of, why there is a focus on things like contamination risks and critical control points throughout processes. When we look at the top non-conformances, here we see the top non-conformances from SQF and BRCGS from last year. I've highlighted and bolded some of the ones that I feel could directly relate to potential physical contamination issues. It's not necessarily a direct cause, but when you look at things as a top non-conformance like temporary repairs, that's things like, where they're using maybe zip ties to secure something together rather than permanently bonding it together, where they're using tape on the walls and things like that. All of those temporary repairs could potentially lead to a higher level of physical contamination risk if those temporary repairs kind of fail and then fall into the product area. You're always going to see things like equipment design and construction. A lot of their identification in that area has to do with hygienic design and things of that nature, but certainly we can look at equipment design and construction from a physical contamination perspective as well. You've got belts that are misaligned and mistracked. The belts starting to chew up can create contamination, and oftentimes contamination like that is very, very challenging to identify. Walls, ceilings, and doors, obviously cleaning and sanitation. And you can see there's a lot of consistency between those two standards of common issues. The temporary repairs are common, the cleaning and sanitation, the equipment design and construction. And having these be still in 2025, 2026, a top non-conformance from these organizations kind of just tells me that there's still a lot of work to be done in these areas where we can still really look at our processes closely. There's a lot of room for opportunity to improve these processes. And again, ideally, what we're trying to do is prevent issues from occurring. I look at particularly a contamination detection kind of in a line of, well, the first thing I can do from contamination risks is try to totally eliminate them from the process. If I can get rid of the risk entirely, that's the best solution. The next step, if I can't get rid of the risk, then maybe what I'm going to do is I'm going to try to prevent the risk from entering into the product flow in some way, shape, or form. Maybe I've got covers over exposed product areas, things of that nature, where we're going to try to prevent it from getting in there. And then kind of the last leg of the stool to stand on is detecting it. If I can't get rid of it and I can't prevent it, well, then if it does get into the product, I'm going to have some way to try to identify that it is in there and hopefully remove those non-conforming items. But again, I think one of the things that's still missing within the industry is when we find contamination, even from a detection solution like a metal detector or X-ray system, we're missing the part where we're supposed to do root cause analysis, figure out where it came from, and then implement corrective actions to prevent it again. And I can see that from the consistency of, foreign material being leading causes of contamination and recalls. Maybe not necessarily in the physical number of activities and recalls that occur. It's often, maybe 3 or 4 in the list of the frequency of occurrence as far as that goes. But we can see over here from a poundage area, it usually affects the most amount of products. We can see here there was 13 recalls, only 13 in 2025, and it created 69 million pounds of recalled product. That's a lot of product. And if we look at it, particularly nowadays when there's a stronger focus on the environment and waste reduction and things like that, that's 69 million pounds of product that ended up as waste in some way, shape, or form. That's 69 million pounds of packaging material that ended up in a landfill somewhere that didn't need to be there. The only reason that it was there is because there was a physical contamination found within that product in some way, shape, or form. And again, to me, those are preventive things that we can do. I think we're going to be challenged for many, many, many years to come to get rid of biological concerns. Microbiological entities will even adapt over time. We might find a way to help sanitize or kill them, but they're microbiological. They're going to adapt in some way, shape, or form and become maybe less immune to those protections that we do. But physical contamination is an area that I truly feel is one of the contamination issues that's somewhat solvable. But it's solvable by, again, understanding that we have great equipment designs, that we have great supplier controls in place, that when we do identify an issue, that we do something truly about it. We figure out where it came from and we figure out how to stop it from ever happening again. I would much rather start to see these numbers and that foreign material recall risk get further and further and further down the line as far as percentage of recalls. I would much rather see this 69 million pounds of product be drastically reduced over time, because again, all that recalled materials just ends up in a landfill somewhere. We're having trouble feeding the world. These are food products that, are now wasted. So there's a big impact if we're able to really kind of have a large impact on this sort of issue. Of course, there's all sorts of different contaminations that end up as far as foreign material within the product. The most common we find are metal, glass, high density plastics and rubber from different pieces of equipment within the production environment. And then you can have some things that might be a part of the product at one point, like a bone, but if it's going into a bone-free or a boneless type product, obviously at that point it shouldn't be in there, and it can be considered a contamination. And then we actually had a client in this week, and one of their biggest problems was stone. They have a vegetable type product, and I guess in the harvesting of the vegetable, they have some concerns with stone material getting through there. So they've deployed the application of X-ray to resolve that problem. And We were doing a bunch of validation tests with them and with all these sorts of different sizes and types of stone material, and ensuring that the system was able to identify those sort of things. But this is very, very common as far as what you see as far as physical contamination that creates all of those recalls and all those millions of pounds of product. As far as the overview of technology, again, we'll just spend a little time on this for those that may not be familiar with them. You have metal detectors, probably one of the most common types of inspection systems out there historically, able to detect ferrous, non-ferrous, and stainless steel materials. Of course, there are different non-ferrous materials, copper, lead, brass, bronze, zinc, those sort of materials. There's different grades of stainless steel, 304, 316. And the metal detector is basically working on a conductivity principle, where basically there's a set of coils inside of the device where we generate an electromagnetic signal. As a conductive material passes through that opening, it affects that magnetic field, and we monitor that, and that's how we are able to identify a detection. And the key point there is that it's a conductive detection device. So the materials, in order for them to be detected, have to be conductive. That's why it's able to see metal, because metal is in fact conductive. But of course, we have different variations of conductivity in the various metal types. Gold is a great conductor. Aluminum we have, and copper we have for electrical wiring, so they're great conductors as well. Stainless steel, however, is not as good of an electrical conductor, which is why stainless steel is more challenging to be identified in the metal detector. So you're going to see a different size of ferrous detection capability than you would a non-ferrous, than you would a stainless steel. That's why we tend to see different sizes within them. Metal detectors will also start to exhibit what we call orientation effect. So depending on which direction, let's say like a piece of wire travels through the detector, it will have a different effect on it. And it has to do with the magnetic field and how the lines of flux rotate around various items. I won't get too technical on it. But the conductivity aspect is also important to understand from a product perspective. Some products are conductive. In fact, you are conductive as a person. If you were to stick your hand inside of a metal detector, you would set the detector off most likely, particularly if it was set at maximum sensitivities, because you're conductive. Just like, I don't advise you to do this, but if you were to stick your finger into an electrical socket, you would get shocked because you're conducting the electricity. It's the moisture in your body. It's the salt in your body. It's the temperature of your body. All those same factors, moisture, salt, temperature, can affect the product that is going through there. So things like fresh meat products are conductive, and therefore we have to desensitize the device just to get the product to successfully pass through there. So it's not like you can just get a metal detector and base all your understanding on its maximum sensitivity capability. The ability of the metal detector will be based on the product and what the product allows you to do. Because obviously you don't want to set up a product that has a high level of false rejects. So we would set up a metal detector to successfully run the inspection in the product itself, and then we would challenge it with the different metal types and sizes in its weakest area, which would be closest to the center of the opening as possible, to identify what in fact it is able to detect. And so that's how we would determine that. So again, those conductive products can be more challenging. Dry, non-conductive products can run at very high sensitivities, whereas those wet, conductive type products, we're going to have to adjust and compensate for that product effect, and then be able to understand what the detector is going to be able to identify. As far as X-ray inspection, X-ray allows us to see a little bit more as from a contamination perspective. We can still see all those metals, ferrous, non-ferrous, and stainless steel. Although, again, with the different types of metal types, there are some metal types that are more challenging to an X-ray system than other metal types. And that's because an X-ray system is working off of a density principle. But because it's working off of a density principle rather than a conductivity principle, we're able to see other materials that are not conductive, like glass, like stone, like bone. So that allows us, X-rays allow us to see a much more diverse range of contamination types. But again, there are limitations within an X-ray machine just as well. The way that the X-ray machine works is again on a density principle. So the more dense an object is, the more X-rays it's going to block or attenuate, and then it's going, that's how we're able to detect them, is we measure the amount of attenuation within the X-ray photons to understand whether or not a material is present. If there's a material present in the product going through an X-ray and it's a dense material, we're able to identify that. You can see here kind of densities on the chart where as you get higher in density, like gold and lead, at 19 and 11, those are much easier detected than, say, aluminum. So again, aluminum is a type of metal, non-ferrous metal, in fact, and you can see it's much lower from a density perspective than your typical ferrous and stainless steel materials, and other non-ferrous metals as well. So it's a density principle for X-ray. So X-ray doesn't care about the conductivity of it. So when we have a wet or conductive product, there's no real need to reduce the sensitivity of the X-ray system just to get that product to pass through there. So we're able to run those products maybe at a more sensitive level than other applications. The other aspect of X-rays, because it's based on density, when you have a very homogeneous product, basically a product that has very consistent density over the whole space of the product. Imagine a block of cheese. A block of cheese, if you were to send it through an X-ray, the image that's generated there just looks like a gray square box. There's not a whole lot of variation in the tones of gray that we see within the image. And so we consider that a very harmonious type product. And then you can take a product like maybe a bag of crisps or potato chips, where you have potato chips laying on potato chips. There's air gaps between potato chips. There's all sorts of density variations within the product characteristics itself inherently. That's a little bit more of a challenge for an X-ray application. In fact, we have systems that are designed specifically for those applications to try to overcome some of those challenges. Because an X-ray system is working off of a density principle to identify contaminations, those varying densities within the product itself can make it more challenging. If I have a contamination that's laying right on top of a chip, okay, I'm able to maybe see that, okay. But if that contamination falls between two potato chips, let's say, in an air gap, well, now there's a difference in density there from the surrounding areas. So it can be a little bit more challenging. And those products, we call it a noisy image, where it kind of looks like an old television screen that we didn't have the station tuned into, and we had to work off of antennas, for all of you that are old enough to remember that. So it was very kind of like a snowy image. There's a lot of contrast within the picture itself. And an X-ray is looking for those contrast differences within the image to identify those contaminations. So a block of cheese, very harmonious in its density, relatively easy to inspect within an X-ray machine. That noisy image, like a box of cereal or a bag of crisps, those are going to be a little bit more of a noisy image, where it may be a little bit more challenging for those applications. But again, there are technologies out there today where we're able to overcome a lot of that density variation challenge and still get very, very good inspection capabilities. So that just kind of gives you a general idea of the two different technologies that are probably most common. Of course, there are other means of protecting against contamination. The first one is, again, don't allowing it into the area. We do that through a lot of the GMP programs, to where we don't allow pens in our pockets, and we don't allow a whole lot of staples on the production floor, because we don't want those getting in as contamination. So we eliminate it as a possibility. And then, of course, there's other technologies out there, such as filtering, magnets, sifting, floating products, and letting the heavy product or the heavy contamination sink in a floating application. There are many, many ways to help to try to control them. Those metal detectors and X-rays are probably the most common electrical means of doing that, where some of these other manners are more of a physical, mechanical type operation to do that. When we look at the value of inspection throughout the process, this is really something that I truly believe will help to reduce that 69 million pounds of recalled products out there. If we start to look at the entire process itself holistically, oftentimes these inspection devices, metal detectors, and X-ray historically have been positioned at the end of the line. It makes a lot of sense to put them there. You've got the products in its final package. There's no further processing that's going to happen. So the contamination risks are relatively, well, they're certainly lower. I don't want to say they're relatively low, but they're certainly lower at that point once it's in its final package and in the closed compartment. And so that's often where we see these devices. However, if you think of the end of the line process, so I've now purchased my raw ingredients, I've now mixed them all together, I've now maybe done some baking or cooling or whatever that further processing is, I've now put them into a package, and then at the end of the line, I find a contamination and I throw it all away. I throw away the package, I throw away the raw materials, I throw away all the time and effort that we took to manufacture it, all the energy that we took to manufacture it. All that really can be seen as waste, and that's simply because we only had that end of the line type inspection. Whereas if we start to inspect the product throughout the process at key points, we can truly start to recognize some increase in the value. If I'm able to, let's say at the front end of the product, let's just consider I'm baking a loaf of bread. Well, that loaf of bread has got some flour ingredient into it. If I'm inspecting the raw flour before I'm even mixing it in with the other ingredients and I find a contamination, I'm going to reject that cup of flour as opposed to rejecting an entire loaf of packaged bread at the end of the line. So you can see I haven't added all that added value into the product towards the end of the line. And that helps to, again, reduce waste, improve the efficiencies. And again, the big picture for me is it helps to be able to identify that root cause much easier. If I'm trying to find out why that fully packaged loaf of bread rejected, I literally have to walk the entire production line from raw material receipt all the way through to final production to try to figure out where the heck that contamination came in at. Whereas at the front of the line, I'm simply rejecting that cup of flour, and I know that flour supplier is the cause of that problem. So the root cause of identification is very easy, and the corrective action can be easy at that point as well, because I would go back to that supplier and say, hey, maybe you need to install some foreign material devices into your process so you're not sending me contaminated product. And that's why I really like to look at the holistic view of all of those process areas. In the receiving area, number one, have validated supplier controls in place, even contractual controls in place, where you're demanding that they send you good quality product, where you even go out to their facilities on occasion and audit their facility and their foreign material programs. You're going to be able to identify those risks very early in the process from that perspective, as well as if you're inspecting them as you're receiving them. Maybe we're offloading a large tanker full of flour through some vacuum system or whatever into a silo, have an inspection point there. And then again, we're rejecting small amounts of material versus an entirely packaged product at the end. I don't see near enough systems in the batching area. I'm usually taking a 50-pound bag of flour or something like that and taking 4 or 5 cups and scooping it into a smaller batch product into a plastic bag that's going to be batch number 1 and batch number 2. And so out of that 50-pound bag, I might have 30 batches of product that I've measured out of it. It's very easy to install a throat style detector as we're pouring it into the bag that's sitting on the scale. Pour it right through the throat detector. If it goes beep, just take that bag and set it aside and then go again. Contact that supplier and figure out why you're finding contamination in the raw materials that he's sending them. don't see nearly enough inspection in this area, and I truly believe there's a lot of opportunities and value improvement by having systems in that location. Sometimes the systems are put in place, and they should be put in place to protect the equipment, like grinding and mixing. Oftentimes, that's where we see contamination from a large perspective get chewed up into smaller, more difficult to detect sizes as they go through processes like mixing and grinding. But of course, the equipment at these locations is also very important to inspect itself, so that we are ensured that the grinder or the mixing blade isn't rubbing against the vat or the bowl that it's mixing in and creating contamination into the product. But inspection prior to these stages ensures that anything that is in there as far as large contamination is detected and removed out of the process prior to going into the grinder. It helps to prevent equipment damage as well. So not only would you be making the contamination more harder to detect as a large contamination gets ground up through that process, but you're also very likely damaging the equipment. So now there's increased downtime that's associated with having to get that piece of equipment repaired and fixed, and hopefully not to have created a bunch of other contamination issues further down the line. That further processing area, this space is usually where I'll try to do things like maybe inspecting product in a throat style detector between a scale system and a bag system. I'm basically inspecting a smaller footprint of product, particularly for metal detector. The smaller you go in detector size, the more sensitive it can be. So I'm taking maybe a very large product as a finished product footprint and inspecting the product prior to going into the packaging in a much smaller footprint, much more sensitive. And then again, I can help to hopefully reduce some of the packaging type waste considerations should I have done it later on down the line. You can also look at this if rather than inspecting a case filled with salad bags, in the case itself, I'm going to run the salad bags individually through a detector. Smaller detector, more sensitive. Typically in these areas, we have a little bit more consistency in the product that's going through there. The more consistency we have within the product, the tighter the tolerances can be set for sensitivity levels. When we have a wide variety of variability in the product, we need to set the detector a little bit less, I don't want to say necessarily less sensitive, but less tight of a restriction on those sensitivity settings to allow for that variation, so that variation, if it's good product, doesn't create false detects. For me, a false detect is probably the worst thing that you can have. That's good, sellable, usable product that has been rejected incorrectly because of the way the system had been set up, maybe improperly. And now that, again, is just wasting time because you're having to go through, investigate that product, try to find the contamination. You don't find it in the end. Oh, that silly detector, it went off again. Usually that's because things aren't set up correctly for properly inspecting the product that's going through there. And again, a lot of these technologies, it's not necessarily how sensitive the technology is, it's how much sensitivity the product allows you to set that technology at. So it's a lot of times is that product, whether it's those conductive products, whether it's the size of the product, all those things can play a factor into it. And the more consistency we can have at the inspection point, those tighter tolerances can be placed within the sensitivity settings. And then, of course, the most common place in that final packaging area, still a great place to do it. I still, believe that should be done at that end of the line inspection, kind of as that final check to say, okay, we did it. Everything is good through there. And if we're finding something at that point, and that's our only point for inspection, we have to understand and kind of coach ourselves that just means everything we did throughout the entire process prior to that failed us. We didn't do a good enough job. We didn't have good enough supplier controls in place. We didn't do anything in the batching area to try to prevent this. Our grinder is chewing up contamination. Our belts are mistracked. Finding contamination at the end of the line just kind of tells us that, hey, everything we've done to prevent this, we didn't do a good job because we found something and there's contamination at that point. But certainly still a great point to have it, and oftentimes might even be the identified location as a critical control point because that's our final chance to do it. Whereas these other inspections throughout the process may be considered preventive type control rather than the critical control point. But I see all those locations as potentially being able to be identified as a critical control point within your process because, again, I think getting the contamination out as early in the process as possible is going to increase your value, reduce your waste, make the root cause identification much easier to identify so that we can adapt and place those corrective actions to hopefully prevent it from happening again. And that, for me, is the key that will really start to have an impact on that 69 million pounds of product. So again, this is just kind of an assessment of the facility-wide assessment and why each area matters, that piecemeal approach, having just a system on the end, or maybe, just having a supplier control in place and not doing anything in our facility. You're going to have hidden gaps in the process. You really should be walking through the entire process with an open mind to understand, how does the technology work? Where can it be deployed within the process? What value am I going to get by having an inspection in this point? And then oftentimes that waste reduction can actually almost become an ROI on the investment of the equipment at those locations. So it's very important to kind of assess that entire process area. Don't just look at that end of the line inspection because that's what we used to do or that's how we've always done it in the past. Begin to consider some of these other areas. There's truly a lot of benefit to that. And then again, optimizing the inspection location. So try to place inspection devices where we have the most consistency within product conditions, within product flow. As we have those tighter, more consistent operational characteristics of the product in production, we're able to set tolerances on these devices much tighter and get better sensitivities out them. Take into consideration that whole big picture. It's not just, okay, we found the contamination, but look at things like how we're going to improve on the waste reduction. Again, if I'm rejecting that cup of flour, I'm able to identify the root cause, know where it came from, and I haven't added all that other value into making the loaf of bread and packaging it just to throw it all away at the end. So there can be a lot of value in understanding and taking an approach such as this. Again, don't ignore that end of the line. But again, I don't feel that should be the only inspection point throughout your process. Not only the value proposition, but even more so, the part that I feel is missing the most is that easily identified root cause and that implementation of a corrective action to prevent that from happening again. I think that's what's going to really have the largest impact on trying to reduce those recall numbers, on trying to experience and understand true value from an ROI from installing devices such as this. I believe that's my last slide, so I've left plenty of time for us to have some Q&A. So again, I thank you for joining today. I've seen some questions pop in the chat, so it looks like we'll have once again another very engaging IFSQN discussion here. So I'm looking forward to getting through some of these questions.
Yeah, that was great, Rob. Thanks very much. Yeah, it is Estefania. You might be new to Food Safety Fridays. We always record them. We always distribute the recording afterwards by email with the PDF of the slides and also the certificate of attendance. If you could mark your questions as a question and it'll go in the Q&A stream, but I'll pick up on them anyway. So, Evangelia, is it possible for an X-ray to detect a foreign body like hair? Comes up every single time. And am I right to say because it's lighter than water, it flows? It won't, or am I wrong?
That's a very good general understanding as to whether or not something is likely to be detected in an X-ray application. If you were to drop it in a glass of water and it floats or sinks very gradually down to the bottom, the chances are getting lower and lower and lower for it to be able to be detected in X-ray, because again, it's based on density. You can think of things like wood, say like a toothpick or something as a good example. It's very hard maybe, but it's not very dense. In fact, that's why we don't like wood in our production environments, because it's porous. It's not very dense. It's just going to sit there and float on top of the water. So things like wood, very, very challenging, if not in many applications undetectable, but in some possible maybe, depending on the product. Things like human hair and whatnot, typically the answer is a pretty strong no. But again, it's very much product related. So as products are lighter in density, density variations in that product may be more identifiable. It's always best if there's a desire to, deploy a particular technology, is to work with a reputable group like Mettler. And, we have application centers throughout the world where you can send products in. We can test them in the actual devices and provide reports on what those detection capabilities are. So you're making an informed purchase decision on what that technology can and can't do for you.
Excellent. That was the longer answer. So my 10 years of webinars with you has, paid dividends there. Question from Darkal. Sir, what is operating temperature and relative humidity of the room where metal detector needs to operate?
There are some extreme temperature areas where the devices, might go beyond their capability of operation, but they're extreme. I've seen these deployed in, cold room applications just outside of a blast freezer. I've seen them deployed in areas where the production is very hot and warm. The products moving through them are very hot. So there's typically not a whole lot of areas where we're not able to have an inspection system based on those characteristics. More so, those characteristics start to affect the product. As an example, if you've got a hard frozen product and then we're inspecting it in a production environment that isn't necessarily all that cold or at temperature, that product begins to thaw out and change its temperature, which can now start to have a more of a product signal and have an effect on what we're able to set that sensitivity at. So they more so affect the product than they do the detector devices themselves.
Okay, makes sense. Another question from Dakar. What is the GFSI acceptable limit of metal size while passing through a metal detector?
Yeah, that's always a stickler is, what size do I have to detect? Most of the GFSI groups, they don't specify any particular size. You'll see language in a lot of the standards and codes. I like to deploy a scenario of we want to detect as low as reasonably possible, right? So if I can get lower, I want to try to detect lower. I want to try to detect as small of a contaminant as absolutely possible. When you look at the regulatory language, often there's an FDA specification for a choking hazard at 7 millimeters in diameter. And that's relatively large if you ask me. But that's really based on a choking hazard. That's not necessarily based on risk of cutting or lacerating a gum or breaking a tooth or anything like that. And those obviously are risks with foreign material in food products. You see some language around the USDA that say products must be manufactured in sanitary conditions, free of filth and putrid substance. Well, what size is that? So there's very little. Some countries do have some size specification. I think Canada's got a 2 millimeter in some of their language. There might be some similar things over in some of the European countries as well. But for the most part, you want to try to achieve as small of a detection point as possible, and that's going to give you your best result.
Okay, thanks. Question from Moni. Is that the same question in a different way? What criteria or size threshold are used to determine whether metallic foreign material represents?
Yeah,
it is. So hopefully that answered your question previously, Moni. Going back to hair, and this is a general food safety question. Mad Haven said, how can we control hair foreign material in the food? So prevention rather than trying to detect it.
Yeah, you tend to see a lot of GMP practices built around that. So wearing hair nets, wearing beard nets. I don't have, in fact, when I do go into a food plant, they want me to wear a hair net. I don't know. There's nothing that's going to fall out that's not there. I pretty much clean shave my head all the time. So, but I would have to wear a beard net. You see some that even take it a step further where they have garments for the arms and things like that. They're typically focused around some of those GMP type requirements. Some plants, even as you walk into the production area, you'll walk through a room that air blasts you, so it takes any kind of debris even off of your clothing and whatnot. Those are the sort of things that you want to start to look at, particularly if it's a common problem and customer complaint for you. Implement some sort of corrective action to try to reduce the likelihood of that occurring at all. Again, oftentimes those are controlled through the GMPs.
Okay. Riva, radio frequency can also affect the metal detector system, right?
Yeah, so if you recall on that little diagram I had of the detector, there are basically primarily one receiver with two transmitters, and the interference can come from radio type frequencies because that's kind of what the metal detector has, a tuning, if you will, similar to tuning in a radio station to a particular frequency. If something is operating at that same frequency of the detector, it could interfere with it. In fact, sometimes if the detector's apertures are looking at each other in a line of sight, so I can see the opening of one directly in front of the other one, sometimes if they are the same frequency, the metal detectors themselves can interfere with one another. And so what we have to do is we have to stagger the frequency slightly through the electronic compensation in order to prevent that from occurring. If you were to put an antenna of a radio directly into or near the detector, typically what you would see is when you key the mic, you would see maybe a detect occur. But if you're sitting there holding the mic and communicating, you're not going to see a constant detection. You're going to see it when you release the mic again, because what happens with a radio such as like a walkie-talkie is when you click that button, it's ramping up through the frequencies to get to its operating frequency. And when it passes the detector frequency, bing, that's where it sees it. So there are ways, and the systems have been built much better than when I originally started back in the early 90s doing this sort of stuff. The technology has certainly improved. Filtering within the systems has improved drastically. So we don't see that too much anymore, but it is a potential to happen. Correct.
Okay. Estefania just said we have an X-ray detector, but the product's density greatly affects our ability to identify it. So just confirming practically what was said earlier. Okay, from Bijesh, if we produce plastic packaging for food industry, is it required to have metal detection features?
Often those sort of requirements, if you're making packaging material, some of the standards obviously have some packaging certifications now built around their standards, like SQF. I believe they have a packaging certification type standard for packaging producers. Oftentimes you're going to get that requirement from a direct customer. Obviously, if I'm a customer and I'm receiving packaging material, I don't want it to have any foreign material in it. Certainly that could get into the product, but even maybe even embedded within the packaging material itself, because I'm going to run that package through a metal detector at the end of the line. And if there's a contamination in there, my metal detector is going to detect it. And then I'm going to have to figure out, is it in the product or is it in the packaging? So yes, I would encourage packaging materials to also very much explore what sort of inspection technologies they can have to ensure that their packages themselves are free of contamination, because it does cause quite a bit of chaos down the road once it's got product associated with it and trying to determine, okay, what is contaminated, the package or the product. We see a lot of contamination still today in recycled cardboard operations. For whatever reason, that process, it's just very, very common that we see foreign material in a cardboard box. And then when we investigate even further, we find out, yes, it's from a recycled cardboard, which is great for the environment. And I definitely am an advocate for that. But yes, packaging material producers should look at physical contamination inspection devices to help reduce that likelihood.
Okay. Question. Question from Jose. Which is the most efficient way to detect low density plastics?
X-ray. No doubt about it. Most low density plastics aren't conductive, so therefore they would be nearly impossible to see in a metal detector. And I say nearly impossible because there are some plastic manufacturers out there that dope or impregnate the plastic materials with some detectable medium, whether it's a graphite type medium that's in there that starts to make that plastic conductive. And even less dense plastic producers are now starting to have materials embedded into the plastic that make them better and more visible within an X-ray technology. But for non-conductive type items, if we were just going to look at it in general terms for plastic, your X-ray applications are going to be probably the most practical.
Okay, question from Rufus. Is there a specific range for X-ray in detecting metalwares in beverage products and sausages?
Beverage products and sausages. Wow, that's a diverse plant. The good thing is all these technologies have a lot of different system variations. So there are applications for obviously conveyed product. There's applications for free flowing and falling product. There's applications for liquids and slurries being pumped through the application. So yes, all of those things could be, you could inspect liquid products as it's in its flow state through a pipe. You, of course, could inspect it once it's in the final bottle or can or whatever it's going into as well through certain technologies. And then products like sausages, again, meat products tend to be a little bit conductive. So it depends on the application. If it was a hard frozen piece of sausage, it's going to be less conductive than if it was a raw piece of sausage going through there. Because as you tend to freeze the product for a metal detection application, it tends to allow us to run at higher sensitivities because of the frozen aspect. If you think of it from a liquid perspective, it's kind of in its solid state at that point, rather than being water. But as it starts to thaw again, temperature and frozen application becomes a consideration. We want to be sure that that product is in fact fully frozen and not beginning to thaw, because as it begins to thaw, that conductive nature is going to start to come back to that product, and that may adversely affect the performance of the system.
Okay. Rukaya, for metal can industry, what's the best to help in scanning foreign body as metal detector is not an option?
Yes, we have many applications for can inspection for the X-ray. That's a very, very common application for a can type product, just because of what you mentioned, they really can't be inspected in a metal detection application because of the can itself being conductive, and certainly trying to detect a smaller piece of metal than this big metal can is going to be challenging. But X-rays are able to meet that challenge and have very, very good inspection capabilities through in there. You want to do a lot of understanding of where that contamination could potentially be in a can application. It could be very close to the sidewall, or it could be very, right in the middle of the can. And those two areas will have different detection capabilities. So again, when we have customers that are looking for X-ray applications and such products such as that, we'll provide testing information and provide the probability of detection in multiple areas throughout that can, not just the easy spot to detect in the center of the can.
Okay. Can I ask you to post your questions in the Q&A, please? Then we can easily identify them. Okay. Question from FY Chan. Which location should we place the test pieces, e.g. top, in the middle, bottom of the product when it passes through metal detector?
All of them. The reality is it's not necessarily where the contamination is in relation to the product with the metal detector that's the most important thing. It's where it is in relationship to the opening of the detector. So if you have a square opening in a metal detector, the center of that opening is the most challenging area, the least sensitive area of the detector. And you can kind of think of it again as your radio frequency, right? As I'm close to the radio station, and I get very good signal and very good reception, and the signal's coming through very strong. There's no static in the music or anything. But as I drive further and further and further out of town, that reception becomes weaker and weaker and weaker because I'm getting further away from the source. Well, on a metal detector, our source is the coils that are wrapped around the outside edges of that opening. So the furthest away I can get from them within the inspection area is that absolute center of the detector. So if your product is lower than the center point, putting your test sample on top of that package is fine because that places the contamination as close to the center as that product would ever allow a contamination to be. But if your product is taller than the center point, then you may want to attach it to the area in which the sample itself is going to flow through that center of the aperture to get the best result. But I employ certainly through validation studies to understand capabilities of the systems is we do it in all of those areas so that we know, okay, in this area, it's the weakest for our application. And then that's going to be the area where and often people say test. I like to say challenge it because that's exactly what you want to do. You want to target the weakest area, the most difficult way to detect that contamination, and ensure the contamination is detected in your application through that challenge test.
Okay. Question from Amorcelio. What's the standard to check metal detector sensitivity when producing coconut milk powder? Anything specific?
Yeah, again, as far as the standard size of material or anything, not there, you're going to be hard to find anybody that actually specifies it, certainly from a regulatory perspective or a GFSI perspective. You may have a demand from a particular customer or client of yours that may say they want to detect down to a certain size, above and beyond that, they won't accept that product from you. That's possible. But you always want to check it as the most sensitive it can be. Again, you want to ensure that regardless of the size of contamination, it's going to be a contamination. Does it cause harm to somebody? No, maybe not. Will I choke on it? No, maybe not. But any sort of physical contamination in a food product, even though it might not be the biggest cause of death or harm or anything very, very severe, it's oftentimes the highest customer complaint because it's something we can see and we know it's not supposed to be in there. I know if I go to a restaurant and I eat a hamburger that's got some microbiological contamination to it and I get sick from it, I'm very unlikely to send a letter to that restaurant. I'm very unlikely to even go to the doctor. I'm just going to lay in bed for the day and feel better in the morning and let it pass. But if I see a bolt sitting in my salad, I might raise some issues with the people and say, hey, what is this? So it's often the highest customer complaint. So you should get down to as small, try to get everything out of it. And certainly if you do, again, have whether it's through a customer complaint or through a rejected item through one of the devices, go through a process of understanding where the heck it came from. How the heck did it get in there? And how the heck can I stop it from happening again? And if you really, really kind of employ that mindset, that's where you'll start to see a real improvement in the process. And that real improvement in the process is the reduction of customer complaints, the reduction of those recalls.
Yeah, makes perfect sense. Rufus, with reference to detector reliability and stability, are there specific frequencies for optimal noise and vibrations?
Yeah, so as far as the different frequencies of metal detectors and whatnot, yes, oftentimes the product that we're running through them will determine which is going to be the better operating frequency for us. So there are multi-frequency detectors that have inside of one detector itself. You can run a number of different frequencies, so a lot of diversity in the products that can run through those devices. Certainly older historic systems may have been single frequency applications, which case kind of, limits what we're able to run through them from a variation in product type perspective. But yes, the frequency of the detector will have an effect on the overall performance. Typically you would see those dry, non-conductive type products, pharmaceutical type products, that don't have any conductivity running at very, very high operating frequencies, which is the most sensitive. And then as we get into those more conductive products, we tend to reduce the frequency so that we can still have an increase in the sensitivity capability, but we're limiting the effect of the conductive nature of the product itself going through there. But yes, frequencies will have an impact on it. There isn't necessarily one frequency that's better than the other for all applications. It's really very much product specific. But again, there are devices out there now that are multi-frequency spectrum, so you're able to run a wide variety of product types through a single unit.
Okay. SOC question: with the ongoing shift toward greater automation, e.g. automated new material handling, weighing and batching, are there emerging challenges related to foreign body prevention and detection systems? What guidance or best practice should be considered to ensure continued effectiveness of these programs?
Well, with anything, in order to understand what the effectiveness is, you want to have really good validation, verification activities built around the technology. Again, we wouldn't necessarily just rely on what the maximum sensitivity capability of any device is for an application that we're trying to deploy it in. We want to understand what those capabilities are at production settings, at all the variations that's allowed it within production and still be considered a good quality product. We want to really challenge again these devices to ensure that all of the variations that could potentially happen through production that would be acceptable to us, that doesn't have an adverse effect on either what it's able to detect or have an increase in the false reject activity that might occur within the device. The only thing that I can really say is that yes, there's an ongoing shift for greater automation within the process. That's why you really are starting to see a lot more deployment of communication softwares and software management programs. We have an offering called Products that basically you can hook all of the devices to, and it monitors all the products that go through there. It has a record of all the rejects that had occurred, time and date stamp, the signal strengths that were, occurred during that time. When you go and do the daily verification activities where you're challenging the system throughout the day to make sure that it's still working, all of those records can be maintained automatically through those systems. There's onboard capabilities within these systems today where you can see a historic event type activity of what's going on there. Whereas it used to be all paper-based, you had the clipboard and whatnot out on the shop floor, and they would sign off, and oftentimes those would be difficult to read. Number one, I know my handwriting is absolute garbage, so I'm about the only person that can read it. So these sort of technologies, help to solve some of those issues where it's automatic data control type stuff. And again, you're just having more systems that are smarter today, that are able to handle the diverseness of the product and the product conditions. The technology is always getting better. We're always implementing new solutions. Again, we have some solutions now for those noisy products with X-ray that were much more sensitive and capable than previous devices. Technology will help certainly continue to improve not only the detection capability, but also documentation and recording of these devices, so it's easier to report to the authorities what's happened throughout the day. I never want to look at it from a perspective of these things starting to eliminate staff or personnel because they're replacing humans. I know that that's always a concern and risk for people, and justly so. But I like to say that it allows them to operate in a more productive area. It's silly to have somebody necessarily walking around all the detectors and writing down what the results were and then going back to their office and correlating all that information and then transposing it into a electronic database and whatnot. All of that can be now done electronically, and that person's role can be focused on more important things. Maybe they get involved in that root cause identification practice and corrective action implementation. The real things are going to have an impact on reducing what we're trying to reduce.
That's great, thanks. Emmanuel, how can we detect glass fragments in food packaging?
Yep, X-ray is your solution there. And again, the X-ray capabilities within glass detection are very good. A lot of it, probably one of the most challenging applications we have related to glass is what we consider glass in glass, where we've got maybe a glass jar of pickles or something that's going through the X-ray machine, and we're looking for, as that cap was applied to that glass jar, maybe it chipped the glass, and so we're trying to find a glass contamination inside of the exact glass container in which we're trying to, that it was deployed in. So that's one of the more challenging applications as far as glass is concerned, where it's glass in glass. But again, the technologies have improved so drastically in that capability, where it is truly a capability of identifying those today. And then certainly glass just is a general contamination in many, many different product variations. That's a relatively easy application for an X-ray. Wouldn't deploy a metal detector in that case because glass is very rarely conductive, and so it wouldn't see it in those applications. But between the X-ray capability and again, some of the other capabilities, whether it's maybe vision or some of the filtering and sieving into the application, those are other means that it can be done. But electronically, you're probably looking at the most successful as an X-ray application.
Okay, that also answers Flora's question, because that was about glass in glass. Dennis is asking, is there any other way for X-ray machine improvement for human hair to detect hair low density ever, in the future?
I can't say no to anything, right? I mean, my goodness, the way things rapidly change today and evolve and whatnot. Yes, it's possible. Maybe someday there's an application where we're able to do that successfully, consistently, and really that's the key, right? I might be able to set the system up in one situation where it's able to detect it, but can I do that with all the variation that occurs within a normal production environment, with all the chaos that can happen within a normal production environment? Those are the things that we have to ensure, is not only can it detect it, but can it do it consistently with all the variations that are going to happen during normal production, not have an increased level of those false rejects. Because again, to me, those are your worst enemy. Is if you have a false reject, that's a system that basically is a good product that ended up in the reject bin, that's causing extra time and effort to go through a rework process for that. It's losing confidence in the device, because if you're finding a reject without contamination, you're like, that thing doesn't work very well. And those are all very, very detrimental to the overall program. So maybe someday, but for us, it's going to have to be a good, successful, consistent type product before we would ever even deploy something like that into the marketplace.
Okay, thanks. Roland's asking, how well do X-ray machines detect foreign bodies in highly dense grains and seeds?
Yeah, again, it's all depending on, and those products can be a little bit more challenging. Not only are they dense, but again, they tend to have that kind of noisy image where there's a lot of contrast within the image itself. And that's really what an X-ray is doing. It's generating an image, and then the computer is analyzing that images for contrast variations. And when you have a product that naturally is contrasting within its image, it makes it a little bit more challenging to see those contaminations. But again, there are ways that we're able to filter some of that noise, if you will, out of the system and then look above and beyond that for the contamination. So improvement in those applications is definitely here today from where it was 5 years ago, maybe. And I'm sure in another 5 years, it's going to be even improved upon what we're at today. We're always going to be seeing a consistent involvement of the technology with the goal of detecting better and smaller. We're always trying to do that through our research and development, and we'll continue to do that. So again, expect continued improvement capabilities through our detection devices.
Yeah, excellent. Reva, for X-ray, is there a standard size for bone?
Yeah, again, as far as contamination sizes, whether the material's bone, metal, glass, stone, it doesn't really matter. There's very few that will actually specify from a regulatory perspective what that has to be. I always look at it again. We want to get it as small as humanly possible. Achieve the best that you can achieve without a high level of false rejects, with multiple inspections deployed throughout the process. There's ways, again, to reduce the likelihood of contamination occurrence, which is really one of the things we should be focused on, necessarily more so than what size can we detect. The size that you can detect is going to be very application specific, where we are within the line, what the product conditions present, the size of the detectors and openings and things of that nature. There will always be factors involved in technology that limit its capability, whether it's in what it can detect or how it detects it. So we always have to, that's why we have to kind of work with reputable organizations that will walk you through that process to truly understand what that true capability is going to be through strict validation testing and protocols to understand that. We never want to give you a false understanding of what to expect from the system, because if you have a high expectation and we aren't able to meet that, then that doesn't necessarily bode well for either of us. So we want to always ensure that we provide that visibility to what those true capabilities are through very, very strict studies and validation tests. And I encourage everybody to go through those processes, whether you're choosing a Mettler-Toledo item or anything else. You always want to be sure that you don't just necessarily rely on what the piece of paper says that it can do, that you truly go through and challenge those devices with all of the potential variations that you feel you can throw at it that you're going to see during normal production, to understand not only how it operates in a nice test lab type facility, but how's it going to operate in our production.
Okay. Question from Moni. What action should be taken if the metal detector test piece is below the validated detection threshold, T-hold/detection limit?
Yeah, I mean, if you have a particular size that it's supposed to detect and it's not detecting it, well, there could be any number of things that are the potential cause for something along those lines. There may be, these are electronic devices. That's the one thing I tell you and guarantee you at some point it will happen. Something's going to go wrong with it. It's going to need a component replaced in it. Just like we don't have televisions forever. I have to replace my television. Seems more frequently now, but thank goodness they're only a few dollars anymore. But that's the thing when you're dealing with electronic components. At some point in time, they may fail you. That's why you want to, not only have good, reputable equipment installed, but you want to have preventive maintenance programs in place. You want to have somebody come out from the factory, maybe on an annual or even maybe, 2 times a year, to inspect and evaluate that system so that they can catch problems before they actually occur and then stop the line and shut the line down. not being able to detect that size contamination from what it was able to detect, again, could be any number of reasons. It could be an issue with the system. It could be a change in the product conditions. Again, temperature, moisture percentages, salt percentages for metal detectors, all those sort of things can affect it. If we're putting in a heavier product or a more dense product than what we did yesterday, sometimes you'll find issues with like seasonal packaging. I know during the holiday time frames, we like to have these nice, bright, shiny type packaging because it looks good on the shelf. But sometimes those packaging materials, if there's any foils in that or anything like that, can have an effect on systems. So there's any number of reasons why it could. What to do about it is understand what the change is, right? Is it a problem with the system? Is it functioning correctly? Or is it something in the product that may have changed and resulted in the condition of no longer being able to detect what we had expected it to?
Yeah, excellent. I appreciate we've run 16 minutes over as usual. We always get loads of questions, but for anybody that needs to, stick to the time, put your certificate in the sidebar, and it is being recorded. But we will carry on and pick through these last few questions. John, can we perform internal verification calibration for the metal detector?
Internal verification calibration. So calibration is kind of a sticky term when it comes to metal detectors. Metal detectors aren't really a calibrated device, not like a scale, right? A scale, we can take a known weight, put it on the scale, it reads incorrectly, and we can calibrate the scale so that it reads correctly. That's not really how a metal detector would work as far as, well, it's supposed to see the 1 millimeter ferrous, it doesn't, so now I'm going to adjust it so that it does. It's not really a calibrated device in that sense. So when you talk about verification, for me, that's more aligned with those validation type studies where we're running multiple samples through there, ensuring we get a detection level of so many out of so many. Maybe it's 30 passes. I want to get a 30 pass success out of 30 passes. And then the verification part of that is then when I would kind of routinely go and ensure that what was validated is still in fact possible through verification activities, more of a periodic testing and challenging of the devices. So yes, those sort of activities obviously are often done in-house to where, you would have a particular validation protocol in practice when we're maybe first installing or deploying a device into a facility, and then ongoing verification activities that happens maybe even multiple times throughout a day. But again, that term calibration is very, very misleading in the industry, particularly when it's related to metal detectors and X-ray devices. Some people try to classify, hey, we calibrate the detector settings to the product, meaning we run product through there and we adjust it so that the product will successfully pass through there, and they call that calibration. But calibration is very much a term that has to be related towards a recognized standard, most often an international standard for calibration. So I don't like to use that term when we talk really metal detection and X-ray because it's a little misleading. So I'm hoping I answered his question correctly.
Yeah, very good. Nitika, we are installing a new MD in our flower manufacturing unit, and I want to understand how to properly set the frequency. What would be the recommended approach for configuring it?
So oftentimes, in particular with like multi-frequency type devices where it has the ability to operate at several different frequencies, many of these devices, ours certainly has what we consider an automatic setup feature, where basically you would set it and run the system through an automatic setup routine where it says, okay, please wait, don't do anything to me. And then it says, okay, pass some product through me. You pass some product through there, and the system itself adjusts all the proper settings so that in the end it's able to successfully run that product. So you'd run it through these auto setup routines, and it would adjust all of those settings, frequency, sensitivity settings, the phase settings, another setting that's often within a metal detector, to successfully be able to inspect that product. Once it's completed that routine, is when you would run, again, what I call the challenge test, where we're running different size and different type materials through there in its weakest location to try to identify what it's able to detect. So it set itself up to run the product. Now we're going to understand what it's able to detect when it's set at those parameters.
Okay, great. Dennis, what will you do if the X-ray machine rejects a product?
Well, oftentimes they're rejecting them into a reject bin or a separate area, that kind of removes it from the normal flow of production. It's always important to have some sort of control over that. Ideally, the bin itself is a controlled bin, whether that's through a physical lock or an electronic lock or mechanical lock, to prevent unauthorized people from going in there who haven't been properly trained on what to do with those products. But those products really should be assessed for contamination at that point, or whatever the quality reason for the reject was. Because sometimes x-rays are used for other quality management as well. So whatever the reason for the reject is, we want to confirm that it was a good reject, and contamination concerns we find a contamination in there. What some people do, and it's not necessarily a best practice, is they will take a contaminated or rejected item, take it out of the bin, and rerun it through the same system. You have to understand that, particularly with loose product that's in a package, again, think of a bag of potato chips in a bag. A contamination in there might have been at the lower part of the bag as it ran through a metal detector, as an instance. That's a more sensitive location, closer to that bottom aperture. So it detected something and it rejected it. But through the activity and the movement of the reject and me taking it out of the bag, now the contamination is sitting on top of the bag and we're running it through the center area, which, as I mentioned before, is going to be a less sensitive area. So what may have happened in that case is the product goes through when I just reworked it. And if I just did that single pass, so first time it passed, it rejected. Second time it passed, it didn't reject, and I let it go on to the consumer. Well, if we look at that statistically, there's a 50% chance that product is contaminated, because that's exactly what happened. One time it contaminated, the next time it didn't. So we've got a 50-50 shot as to whether it being contaminated or not. And because there's the possibility of that contamination shifting places and variations in detection capability, the first time when it was on the bottom of the bag, it may have been a contamination piece that's even smaller than what I'm trying to detect for. So that's not necessarily a good practice to have that sort of mentality when re-inspecting product. If you're going to re-inspect it through that same detector, pass it through there multiple times at the very least. Move that product, flip it upside down the next time you run it. Shake the product up. Try to create some, movement in where that possible contamination is. And if you ran it through there the first time it was detected and then ran it through there 10 more times and never got a detection, okay, now we might have a higher likelihood of it actually being in there for a false reject. But then you need to figure out, well, why did we have the false reject and how do we correct and prevent that from happening? Every time there is something in the reject bin, I see that as an opportunity for improvement. Either it's really contaminated and I need to figure out where the source is and put an improvement process in place to prevent that from happening again, or it was a false detect and I need to put an improvement process in either how I'm running the production, how the device is set up for inspection, whatever the case may be. But please, please, please don't just give yourself that 50-50 shot of having a contaminated product or not, because at that point you very well may be contributing to 69 million pounds worth of product waste.
Yeah, 100%. Earl, can the technology that you spoke of that are capable of monitoring and keeping data of detection, rejection be accessibly remotely by the providers for troubleshooting?
A lot of what I spoke of with the products is more of a data management type area. So, okay, yes, it will register and record maybe some fault activity at the detector, but it's not necessarily something that we are dialing into the system and doing any sort of monitoring on. Remote, diagnostic type stuff is kind of capable. A lot of times where our challenge is really from the facilities allowing us to have insight into their, a key into their system. That's often where we see more resistance than anything. Again, I think as technology improves and moves forward, we're going to start to see more and more and more of that sort of diagnostic type capability. But I think the challenge is in things like when we talk about cybersecurity and the security of our data and all that sort of stuff. That's where we start to see a little bit more resistance on really allowing us the ability to see in the machines. And of course, as we get more and more cybersecurity risks out there in situations where in the past few years, we've had a couple of cases where the systems had been hacked and had major effects and shut down productions for major producers, or even hijacked information, and so they had to pay to get their information back, all that sort of stuff. We want to avoid all those sort of risks and ensure anything that we do deploy along those lines, we've done our best in due diligence to ensure that those risks are at their absolute minimum. So I think that's probably why that sort of technology hasn't evolved as rapidly maybe as we see things developing technology wise throughout in other spaces. But anything that we do along those lines, again, that's one of our key priorities, is ensuring the security of the data, the information, the infrastructure, so that we can hopefully prevent any adverse effect from having that deployed within a facility.
Okay, last couple now from David. To improve X-rays, the focus geared towards imaging and resolution.
Yes, we are seeing some of that. Again, we have capabilities now within it, like an X-ray machine, at looking at the image in different ways to clean up some of that quote-unquote noisy image, so that in those very, very density diverse type products, we're able to get better inspection capabilities because of that. That tends to be, it has a lot to do with the imaging and resolution, because again, particularly for X-ray, that's what it's doing. We're developing an image through the X-ray physics, and then really it's the computer that's then analyzing that image. So the ways that we're able to do various algorithms through the computer, the ways that computers are getting faster and more powerful all the time, all of that's going to add to the improvement of the overall detection capability. And again, even as that improves towards the future, we're going to see even further advancements in that space.
Okay, super. Question from FY Chan. Do we need to calibrate the test piece of metal detector, or should we just replace it with a new one after a few years?
Yeah, it's recommended, particularly for activities such as validation activities, that we're using at least certified test pieces. So we want to be sure that if the test piece says it's a 1 millimeter ferrous, that we have some proof that it is in fact a 1 millimeter piece of ferrous in there. There's often a question as to, well, does the certificate, need to be, we need to replace it every year because that certificate is a year old now. I always look at it from a perspective of, you want to look at, if you have a certified test piece, you want to look at the integrity of that test piece, making sure that if it's a laminated test card, if the laminated test card is falling apart and the ferrous sample in there is beginning to rust because it's got some moisture into the card somehow, yes, replace that. But oftentimes we'll see people get a set of certified test samples for activities like validation, but for their daily operational checks, they may use another set that's not necessarily a certified check. Oftentimes those daily verification checks are really just to reinforce that the system is in fact working. And often people do that more frequently because they want to have less of an impact on the amount of product that they would potentially have to rework if they discovered that something wasn't working correctly. So that's why they would do that more frequently. I always say that in those instances, I often question them on how confident they are on their system. Obviously, if I'm having to test that thing every 5 minutes, that tells me I don't have a whole lot of confidence in the system. I want to understand why we have a low confidence in the system. Is it because of false rejects? Is it because it doesn't always work? Let's understand exactly why that reasoning is, and then hopefully try to increase the confidence in the system's ability based on either how we have it set up to correctly and successfully inspect the product, how we're truly challenging it during these tests rather than just throwing the test card on the belt and then seeing it go beep and picking the test card up and watching the reject device operate. That's not a good test, right? That tells me if I have a contamination on the belt, my reject is going to fire. It doesn't tell me anything about a contamination in the product at production speeds. Will it actually kick off the right package? All of that we can build confidence in the program if we do these assessments in a much more diligent way. And of course, we're happy to help assist in developing those challenge tests, in conducting validation studies with you. We want you to have confidence in the system. But if you still want to inspect those products very frequently due to the amount of product that could be affected based on if something were to go wrong, that's still not a bad practice.
Okay, super. On that note, I think we've done it all. 32 minutes over the hour, but well worth it. Excellent presentation, and as always, lots and lots of questions and thoroughly answered by yourself, Rob. So appreciate your time today, as ever. And we will be seeing you again this year. So
I'm sure.
Yeah. So
it's always great. Thanks for again, the IFSQN community. You guys are just top notch. I love all the interaction and everything. It's definitely one of my favorite things to do is come join you and spend some time. So looking forward to the next time.
That's great. Have a good weekend, Rob, and same to everybody else. We'll see you actually in 28 minutes on the next Food Safety Fridays. It's a double header today. So if you've not registered, get on the website and register now and get your link we'll grab a cup of coffee and we'll see you soon. So thanks, Rob. Cheers.
Wonderful. Take care.
Bye-bye.
Bye-bye.